Hello everyone, I am Assistant Professor Komal Shinde, and in today's lecture we are going to discuss about hydrogen spectrum. So in last lecture we have already seen there are discrete energy levels. Suppose for means there are different orbits are there, n1, n2, n3, n4, and when electron make a transition in between this level we will get emission spectra. Fine. Suppose frequency of emitted radiation we will find out from equation 9. En is equals to minus z square e power 4 m 8 epsilon naught square n square h square. Suppose I am finding the energy for E1 and second is E2. Just you need to substitute the n value 1 and 2. So you will get this relation, and if I minus this 2 E2 minus E1, then what I will be left with, this z is common, e is common, m is common, epsilon naught is common, then h square is common. So I will take all the common terms in outside the bracket, and in bracket I will left with the 1 by n1 square minus 1 by n2 square. So this is the this is the difference between the two energy state. Delta E is equals to, for Z is equals to 1, that is hydrogen atom, m e power 4 8 epsilon square h square in bracket 1 upon n square minus 1 upon n2 square. Okay, so if I calculate this one, m e power 4 8 epsilon naught square h square, it is coming out to be 2.18 into 10 to the power of minus 18 joule. So basically, according to the Bohr's postulate, delta E is equals to h nu. Just if I substitute here h nu, and if I divide by this h, then I will get a frequency, that is m e power 4 8 epsilon naught square h square in bracket 1 by n square minus 1 by v square. And if I take all these are constant, m, e, epsilon, h, and if I substitute and I calculate, I will get 3 into 2 9 into 10 to the power of 15 in bracket 1 upon n square minus 1 upon n2 square hertz. So this is the frequency. From the frequency you can find out the wave number, because there is a relationship between the frequency and wave number. So frequency nu is equals to c into wave number. So c is the velocity of a light, and if I substitute this relation, I will get wave number is m e power 4 8 epsilon square h square c in bracket 1 by n square minus 1 by n2 square. So putting the constant r, so if we calculate that value of r, it is coming out to be 1.09678 into 10 to the power of 7 meter inverse, and this r is nothing but Rydberg constant. Let us see what are the defects in a Bohr's atomic model. So according to the Bohr, the radiation results when the electron jumps from the energy, one energy orbit to another energy orbit, but he did not explain how these radiations occurs. Okay, then Bohr's theory explained the existence of various lines in a hydrogen spectrum, but it predicted that only one series of a line exists, and later on it was realized that the spectral lines that had been observed through thought to be a single line was actually a collection of several lines very close to each other. So Bohr theory successfully explained the observed spectra of a hydrogen atom and the similar ions like He plus 1, lithium plus 2, Be plus 3, etc. But it cannot explain the spectra of polyelectron atoms. Next, if the substance which gives the line emission spectra is placed in a magnetic field, the lines of a spectrum means that will split up into the number of closely spaced lines, and this phenomena is known as a Zeeman effect. And using Bohr's theory, we don't have any explanation for this effect. So, fifth, if a substance which gives up a line or the emission spectra, and if it is placed in an external electric field, then the line of a spectrum gets split into the number of closed spaced lines, and this phenomena is known as a Stark effect. So Bohr theory has no explanation for this effect as well. Means with the help of Bohr's theory we cannot explain the Zeeman effect as well as the Stark effect. Then Bohr suggested the circular orbit electron around the nucleus of hydrogen atom But later it was proved that the motion of the electron is not a single, means not in a single plane, but it takes a places in a three-dimensional space. Means this model is actually like this. Okay, so it is not a single space model. Then Bohr assumed that the electron in an atom is located at a definite distance from the nucleus and is revolving around it with a definite velocity, that is, it has a fixed momentum. This idea is not in agreement with the Heisenberg uncertainty principle, which states that it is impossible to determine the exact position and momentum of a particle simultaneously within some certainty. So these are the drawbacks of this Bohr atomic model. Thank you so much.